Hello, I really didn't like the video on AP Classroom for this last part of section 110, so I'm going to walk you through a problem on paper here, and hopefully it's understandable using your graphing calculator rather than the table in the formula sheet. We will look at that in class a little bit, but since you'll have your calculator during the exam, I'd rather you learn how to work with that. So they use an example where they have systolic blood pressure for patients at a local hospital. The distribution is normally distributed with a mean of 110 and a standard deviation of 10. Okay, so whenever you get a word problem like that, the first thing you're going to do is draw a rough draft of the picture of what you're working with. So typically you want to have the mean in the middle and 3 standard deviations in each direction. And remember, your 1 standard deviation mark is kind of the inflection point for the graph where it goes from spilling water to holding water. Okay, so you don't have to be a perfect artist, but especially on an open-ended question, this is a very good visual aid to work with. Okay, so I have just a few questions that match up with some of the things you might see on an exam. So the first question is, how many standard deviations from the mean would 124 milliliters of hemoglobin represent? So you would use your z-score in order to answer a question like that. So the same z-score as before, but just using the symbols for mean and standard deviation that go with the normal distribution, and you plug in the values that you work with. So you're identifying 124 as a value of interest, your mean is 110, your standard deviation is 10. Okay, so you do the subtraction on the top, that gives you 14 divided by 10, which is 1.4. So what that means is you are 1.4 standard deviations above the average for blood pressure in this particular case. Okay, make sure you say the above there. That's really important. And that is what your z-score tells you. Okay, another typical question might be like this, and this would typically be a multiple choice question, an open-ended question. You would want to show some work here. Let's say, what proportion of the patients have a blood pressure between 115 and 130? And again, it's very important that they say that this is normally distributed. Otherwise, you couldn't really come up with the answer. So this is where our calculator comes into play. On a multiple choice question, all you have to do is hit your VARs button, so second VARs, to get to your distributions. And again, we're using normcdf, so option 2. Now your lower bound in this case, as we said, was 115, and our upper bound was 130. 115, 130. Okay? It is important here that we change our mean and our standard deviation to the mean and standard deviation of the problem. If you don't do that, then your answer will be wrong. Okay? So lower bound is 115, upper bound is 130, and you type in the summary statistics for this situation. Then we can just simply paste this into the formula, and it gives us an answer of about 0.2858. So what does that mean? About 28.6% of patients have blood pressure between 115 and 130. And I know that's a pain for some of us to write that out, but again, that is the expectation of what they want on the AP exam. You could, if you wanted to, you could create z-scores for these and use the z table that they provide, but since we have our calculator, that's perfectly acceptable. Okay. A final question that we'll look at in this video is what proportion of patients are above 135? And I want to remind you too to kind of look at your graph here to figure that out. So the 135 mark is right around here. So you're going to see it's a really small percentage, less than 2% most likely. If you remember a little bit about the empirical rule, the previous question, part B, we were looking between say here and here. So that looks like, you know, a decent chunk, maybe 30% of your data in this area, so that kind of matches up with our 28% that we got. So just look at the graph and that'll help you figure out what you're wanting, what you're working with here. So we're looking at this proportion towards the end tail, and how to work with your calculator on that is we don't have an upper bound, so we're just going to have to come up with a very large number that represents every possible outlier way to the right here. So you use your normal distribution menu again, so second vars gets us into the distributions. Option 2 for our CDF, or again C stands for cumulative area under the curve. So this time our lower bound is going to be the 135 from the problem, and we don't really have an upper bound. So to cover all possible outliers, I just hit a bunch of 9s in there until you have 4 of them is very much getting rid of any possible issues with the problem. So lots of 9s in there, and then again make sure you have the proper mean and standard deviation for the problem. If you were looking for the other tail, you would just reverse these and make the lower bound negative with a bunch of 9s. Okay, so for this specific problem though, we were looking for the upper tail, so you just go down and hit paste, hit enter one more time, and it gives us a value of 0.0062. So 0.0062, and what that means is about 0.6% of patients have a blood pressure level above 135. Okay, so hopefully that helps you work through problems today. Next time what we'll do is we'll learn how to work backwards. I'll give you the area under the curve, and you'll be able to work back to the x values on the x-axis. But for now, this should get you through the problems for today. Thanks so much for watching.